Alright, so let's take a look at some problems that are similar to what's going to be on the test tomorrow. So first 5 problems on the test are going to be graphing, just basic sine and cosine. Okay, there'll be a mixture of each type. So let's start with a phase shift. So phase shift, I'll do a phase shift with sine. That's when you add or subtract a number after the variable, like x plus pi over 2. Okay, so that's a phase shift by pi over 2. But we have to know which way it's shifting. Okay, when you do plus pi over 2, which way does it shift? To the left, right? Plus shifts left. Minus would shift to the right. Yep.
And then multiplication is like up and down, correct?
Multiplication is a stretch.
Okay.
It could be a stretch left and right, or it could be a stretch up and down. Depends where you put the multiplication.
Okay.
You putting it inside or you putting it outside. All the stuff that's inside the parentheses, that's left and right. Whether it's a shift left and right or a stretch. We'll do a stretch after.
So if it's just outside the parentheses, that would be like
Vertical. Could be a vertical stretch or vertical shift.
Okay.
If it's outside the parentheses. Okay, so if we're going to do a phase shift, we're going left and right. What values don't change?
It's gonna be y.
The y's don't change.
That'd be like 0, 1, 0, negative 1, 0.
Yep. So for your y values, you fill those in.
How do you get those? Like,
That's from the original tables on Monday.
And won't that only change if it's like 2 sign in parentheses?
If you put a 2 in the front, that'd be one way to affect the y values. We'll do one.
And that would change the fact that it would be 0, 2, 0, negative 2, and then 0.
Yeah, that'd be any up to 2 change. Yep.
And if it was like a 5, like a far out there number, would it be still 0, 5, 0, negative 5, 0?
Yeah, we'll go through one. Okay, so now there's your x values. And now to get the new x values, what do you do to all the old ones?
Divided by 2. No, divided by...
Well, it's a phase shift, so phase shift involves either adding or subtracting.
Which is add, right? It's plus.
Nope, do the opposite.
I need it all along.
So with the phase shift, subtract pi over 2. Because remember, we want it to shift to the left, right? So if it's going to go to the left, you have to subtract. Now, some of these already have common denominators, some don't. So the first one, 0 minus pi over 2 gives me negative pi over 2. Pi over 2 minus pi over 2 is just 0. Now we've got pi minus pi over 2. Common denominator would be?
Maybe pi.
2.
2.
So double the bottom, double the top. All right, so we were just saying common denominator here is 2. So we got 2 pi over 2. Take away 1 pi over 2 gives you
Pi.
over
Wait, what? Oh, 2.
No.
2. Next one's good. I already have a common denominator. 3 pi over 2, take away 1 pi over 2
2 pi over 2.
is 2 pi over 2. Or we can reduce it to pi. So now if you look at the pattern, negative 1 pi over 2, 0 pi over 2, 1 pi over 2, 2 pi over 2,
3 pi over 2.
3 pi over 2. If you don't see the pattern, do the common denominator one more time and you'll get 3 pi over 2.
Can you do that in a calculator or no? I guess you
Nope.
put pi minus pi over 2.
Nope,
And,
it'll give you a decimal.
yeah.
So with the table, you pretty much just subtract or add, like depending on what's in the problem on top.
For a phase shift, you do the opposite of what you see. So it's 4 different transformations, different rules for every one of them. This is the first one, phase shift.
Okay, I'm good then. That's all I was like confused on.
Yep. All right.
But
So y-axis, just label it 1 and negative 1. X-axis, put your labels. Negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi. This other label, I don't really have a good space. I'll just squeeze it in.
If you don't label on the test, I can give more. Like I say, use maybe the graph. You don't really label on the test.
You lose credit.
If you lose credit. So if I just like, it's like a standard graph, and I don't write down those numbers explicitly, I'm gonna lose credit.
And I think the graph is only worth 1 point, so it's kind of hard to give, I guess, half a point. But yeah, you'd probably lose credit for the graph part. So 1 point for each x and y value. So 10 points for the table. And I figured the graph is either worth 1 point or 2 points. If it was worth 2 points and you didn't label it, I'd give you half credit. So, negative pi over 2, 0, 1, 0, negative 1. I didn't even need to go as far as 2 pi. I labeled extra, but that's okay. And there's your graph of sine. It's shifted to the left, pi over 2. Okay, so that's a phase shift. So the other three we have are amplitude change, period change, vertical shift. We can do one of each, or if there's one that you don't need to see, we can skip it.
Can we do one of each?
Yep. So let's do, that's a more time-consuming one. Let's do a quicker one. Vertical shift. Vertical shift is pretty much what the name says. It shifts up or down. We just did sine, right? Let's do cosine. Cosine. X plus 3. What makes that different than a phase shift? It's still plus something.
So just add 3 every answer at the end because it's plus 3.
Well, how do you know it's not a phase shift?
Because it's the x in parentheses by itself.
Right, the x is by itself. Even if you take the parentheses out, you have to group the x and the 3. That's a phase shift. Okay, when the number is grouped with the letter. Okay. Doing it like that, vertical shift.
Is it going to be labeled on the test just to be sure? Or is it going to be labeled vertical shift in the test?
Nope.
Okay.
Nope. You'll just have an equation. And you'll just have to say y equals, and then you have to graph.
Fine.
Vertical shift. We're going up and down. So what's not affected at all?
X.
X. And that's good because the x's are the ones that are harder to work with. Okay. So all the x's stay the same. 5 points if you write that. And now the y's. What are the originals for cosine?
0.
No, 1, negative, oh wait, 0, negative 1, 0, 1.
Yeah. Now we're going to add 3. So 4, 3, 2, 3, 4. I told you that would be a much quicker one, and it is. The arithmetic's a lot easier.
You just graph that.
Do you want me to graph, or are we okay with the graph?
No,
Okay,
it's fine.
So you would, like, there'd be a graph there.
Yes, you now would have to graph that. So you would shift everything up 3. Okay, so that's a vertical shift. Let's do another quick one. Amplitude change.
Seems like I had a hard time with on the test, not on the test, on the homework, the amplitude change and the period change.
Okay.
Not so much that I had a hard time, but more like I don't know if I did it right. So.
Okay, well, we'll go through it. So we went through the 2 rigid transformations. Rigid just means it just takes what you have and slides it somewhere else. Up, down, left, right. These transformations start stretching out what you have. Okay, so it's going to stretch it or it could compress it.
You graph this as well?
Oh yeah, yep, you're going to have to graph each one of these. So amplitude change. Amplitude is the what of the graph? It's the height. Height implies up and down, vertical. So we are changing the height, which means which column stays the same.
X.
Well, y is the height, right? Y is the up and down, so y's are going to change.
Yeah, X.
X's stay the same. Okay, so 5 points for the x's. And now the original y's were 0, 2, 0, negative, whoops. I'm telling you the final answer.
I was gonna say, I was like, that doesn't.
0, 1, 0, negative 1, 0. Actually, I wasn't even quite telling you the final answer. I don't know what I was doing. Now, what are we going to do to all those numbers?
Minus by 2.
Well, amplitude change is multiplication. So
Multiply by negative 2.
multiply by negative 2. Yes. So now that would stay as 0.
So you wouldn't do the opposite for that one?
No, don't do the opposite. You do exactly whatever you see right there.
Okay.
So 0, negative 2,
0.
0,
2.
2, and 0. Now, separate question, what if I ask, what's the amplitude of that equation?
2.
2. Now, what would be the amplitude now?
-2.
Still 2.
Oh.
Okay, amplitude is a height. Height is a distance, so that's always positive. So the negative has no effect on the amplitude. What the negative did do was flip the graph. It caused it to flip. So any questions on that? So that's your amplitude change. And how about graphing it?
It's just the same as graphing it regularly, right? Except
Yeah.
you can change the scale if need be.
Yep, I would change my y-axis to go by 2s.
Yeah.
Yep, and label your x-axis. Period change. So period change is when we stretch or compress the other way along the x-axis. So let's do a cosine. So period change, stretching and compressing along the x-axis. So that means the y's stay the same. Okay. What are my y values for cosine?
0. Wait.
1, 0, 0, -1, 0, 1.
1, 0, -1,
0, 1.
0, 1. Yep. And now, these are my original x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. And what are we going to do to all of those?
Times them by -2. Oh, wait, no, wait. Times it by the reciprocal.
Yes, you can multiply each of them by a half, or you can divide each one of them by 2. Same thing. I think it's easier to just think about doing it as a half, then you don't have fractions over fractions. Okay, so 0 times a half would be
0.
0. Pi over 2 times a half,
Pi over 2.
pi over 4. Yep. You multiply straight across when you have product. Pi times a half,
Pi over 2.
so half of pi. 3 pi over 2 times a half.
3 pi over 4.
And last one, 2 pi times a half.
Just pi.
Just pi. And there's your table.
No. What about the equations where you connect that? Word problems and look like you were giving that like Tuesday or Wednesday. It was Wednesday.
Word problem.
You define the amplitude, the division, or the denominator, the range, and then like.
So we just went through one of those. I asked you what was the amplitude, and then I erased the negative. So we did that on this one. For this one, the kind of question I would say is, what is the period? So now we know how to find the period of all 6 trig functions. What's the formula for the period for cosine?
2 pi over b.
Yep. 2 pi over b. And b in this case is
2
2. So what's the period of this?
pi.
Pi. That means this graph is going to do its whole pattern in pi radians versus 2 pi. So we've shortened it. We've compressed it.
So if there's nothing in the parentheses with x and would it just be 1?
If there's no number in front of x,
Yeah.
yeah, then b would be 1, which doesn't have any effect on the period at all.
So it'd be 2 pi for the answer.
2 pi would be the answer, yep. If there's no number in front of x. Now, what would be the period if I did that?
Still 2.
Or do you add 3 and 2 together? 5.
No, it's either. I don't know.
I think I said 2, right?
Is it still 2? I don't know.
I don't think it ever was 2.
What?
Period?
Oh, the period. I thought you were asking like to plug in for b, sorry. Will it still be pi?
The period would still be pi. If you shift something up and down, that has nothing to do with the period. If you stretch something vertically, that has nothing to do with the period. Okay, the only number that affects the period is what's in front of x.
Even if you like add or subtract the number inside the parentheses?
That would just shift left and right.
Okay.
So if you added or subtracted a number inside the parentheses, all that would do is this.
So if it was like
That's not stretching
so
or
if it was like
compressing.
4 pi minus 2x, it'd still be 2.
Yep. Well, b would be 2, but the period would be pi.
Yeah.
Right, so that's one each. And then the last graphing, sine and cosine, will be multiple transformations.
How many are those on the test?
One.
Are there going to be secant and tangent?
Yep, there will be problems about secant and tangent.
How many?
All right, so let's look at a multi-transformation. What two transformations do you want to combine? We'll do two, and you pick two.
Can we do period change
Phase shift.
and phase?
A phase shift? Okay. So those are both things that are inside the parentheses. You didn't give me anything on the outside. So let's do cosine of, let's do 1/3 x minus pi. So the minus pi, which transformation is that? My phase shift or period change?
Phase shift.
That's my phase shift. Phase shift is always the first one. Okay, so phase shift, then period change. We had that order. Make sure you know that order. Okay, so if we start with a phase shift moves it which way?
Sorry, say that again.
Phase shift will move your graph which way?
To the left or to the right?
To the left or right. So for now, let's keep all the y values the same. 1, 0, negative 1, 0, 1. So y values. Now, what are we going to add or are we going to subtract?
We're going to add because we're moving right.
Yes. Phase shift, perfect. Always do the opposite. We're going to add pi. Some of these are very quick. Okay, what's 0 plus pi?
Pi.
Pi plus pi?
2 pi.
2 pi plus pi?
3 pi.
3 pi. And the other ones, if everything is equally spaced, are just halfway between. Well, if that's 1 pi, and that's 2 pi, what's right in the middle of 1 pi and 2 pi?
1.5 pi.
Yeah, you could say 1.5 pi, or if you want to think of that as a fraction, 3 divided by 2. That's the fraction 1.5. So 3/2 pi. Or if you don't want to do it that way, find a common denominator, you'll get the same answer.
Is 3/2 pi? Oh wait, never mind.
And you can write this a couple ways. This is
Yeah,
the
that's
same,
what I was just gonna ask, but then I realized that it is the same thing, so
Yeah.
then I stopped myself.
same thing.
Okay.
Yep. And then what's halfway between 2 pi and 3 pi?
5 pi over 3.
Be 5 pi over 2,
2.
right? Because halfway between 2 and 3 is 2.5. And 5 divided by 2
Oh yeah.
is 2.5. Okay, so there's your phase shift. All right, so you did two hard ones in the same problem. So that was the first one. Now we have a period change. Okay, I think the x's, those are definitely harder to work with. The y's would have been easier. But this is good. What are we going to do to all my old x values now?
Transfer.
Well, the x's are going to change, right? Because now we're going to do a period change. So we're going to stretch or compress it horizontally. So the x's are going to change. The y's stay the same for this whole problem. You guys didn't give me anything on the outside of the parentheses to do, so
Okay.
y's never change. But what are we going to do to all the old y values? All the old x values?
Times it by 1/3.
No, times it by 3.
Times it by 3. Divide it by 1/3, or times it by 3. I think it's easier to just think of it as times it by 3. So what's pi times 3?
3 pi.
3 pi. Now the next one, if you multiply that by 3, you get 9 pi over 2. 2 pi times 3?
6 pi.
6 pi. 5 pi over 2 times 3?
15 pi over 2.
The last one is 9 pi. So if you look at that, you're like, wait, what's the pattern? It doesn't look like there's a pattern. That's a pattern. That's 3, 4.5, 6, 7.5, 9. You're adding 1.5 each time to the number in front of pi. So the next one would be 10.5 pi. And that's it. That's your table. And that's probably as hard as it could get because you had two transformations that were both dealing with the x-axis. All right, so we already went over how to find amplitude and period. Any questions on that? No graph, just find the amplitude and period.
But for secant and tangent, we're finding the period, it's different, right?
Secant and tangent are different from each other. You use different formulas. Secant, cosecant, sine and cosine all use the same formula. Tangent and cotangent use their own separate one.
Oh, that's what I meant, cotangent.
Yep. Let's just try this 2 sine 3x plus pi minus 5. So find period and amplitude. Okay, let's start with the period, which for some reason they use the letter T. I don't know why.
Yeah, I know. It's weird.
I'm not sure. What would be the period here? 3 is part of the calculation to find the period, but it is not the period.
Sorry, I keep getting confused.
Oh yeah, I was thinking B and like.
It's 2 pi over 3.
Yep. There's your period. What's your amplitude?
3. 2, 3. Oh no, wait. Sorry, 2.
2. Does that necessarily mean that the highest value the graph hits is 2 and the lowest is negative 2?
Sorry, do that again.
So does that mean the highest this graph would go is 2 and the lowest is negative 2? No, because it's been shifted. So if you didn't shift it, then a graph with an amplitude of 2 would look like that. But even if you do this, that's still an amplitude of 2. Doesn't mean the highest it goes is 2. Now the highest it goes is like negative something, and the lowest is negative something. So the amplitude is just the difference between the highest point and the lowest point. How many units apart are they? Okay, so different question than the highest and the lowest y value. Okay, any question on finding amplitude and period? All right, so there'll be 3 or 4 of those types of questions. And then we did some solving on the calculator. So solving on the calculator, you pretty much graph something in y1, graph something in y2, see where they cross.
Is there going to be those inequality equations on it too? Like the ones we had for homework?
Mostly equations, not inequalities to solve.
So those ones are hard.
Okay, so let's try to solve this one. I want to know where cosine 2x equals 0.7, and I only want you to give me answers between pi and 2 pi. So first of all, if you were to graph cosine 2x at 0.7 forever, how many times would they cross? That would be a wave, and that would be a horizontal line.
Oh, you can do that on the calculator today, right?
Right, and if you zoomed out, how many times would they cross each other? If you just kept zooming out forever.
Oh, like an infinite amount.
Infinite, right? Cosine 2x is going to look like this. I know that the highest cosine goes is 1, and the lowest is negative 1 in this case. And a line at 0.7 is going to look like that. So it's going to cross infinitely many times. But I only want the answers between 3.14 and 6.28. All right, so let's see if we can get those. So graph cosine 2x, graph 0.7, And in my window, tell the calculator to only look at pi to 2 pi. Don't even look at anything else. So let's put in pi and 2 pi. You can do calculations right in the X max. I don't know if you saw me do that today. But if you can type in like 2 pi divided by 6, and it'll put the decimal for you. All right, let's hit graph.
Oh, then you just did the intersect thing, right?
Yep, so there's my cosine. I might have to zoom in a little bit. You can see it.
It happened twice.
It's happening twice. So second, calc, intersect. Now if I just go to the left a little bit, that should be enough to get me the point on the left.
And you're looking for the x equals,
Yep, that's one.
So when you did the window thing, did you only change the x?
Yeah, I didn't change the y, because I know it only goes from 1 to -1. So I could have set my y value a lot closer here. I'm kind of zoomed out pretty far on the y-axis, and I don't need to be. Okay, other answer, 5.89. Any questions on that? All right, now what if you had a problem, let's say you did the whole problem out, you calculated the intersects, and for what you circled there, you got these two numbers. You got 4.71 and 1.57. So you got those two numbers. And on the test, I gave you choices of pi and 2 pi. That's the correct answer. 3 pi over 2 and pi over 2. Or apple and sneaker as the choice. So, what choice would be correct?
A.
this was in the parameters.
Well, again, this is its own problem. So let's just say this is something separate, and these are the two answers that you got. But you look at now the multiple choices, and you don't see those answers listed.
Would you go with what's closest, or what would work?
Well, how would you figure out which choices match up with those?
Convert them to, like, having pi next to it.
Yeah, so how would you do, well, I mean, the first one we already know, but
So it would be B.
yeah, it would be B, right? Because you just take, and if my answers are not decimals and your answers are, we'll change my answers to decimals. 3 pi over 2, 4.71. So that's that one. And pi divided by 2, pi divided by 2, 1.57. That's that one. The correct answer is B. So the reason I'm showing you that is because the calculator is never going to give you a fraction. Calculator is always going to give you a decimal, and it might not match up. All right. So any other questions on solving sine and cosine? Pretty much the first 14 problems on the test are
Questions are there?
17.
Oh.
So the first 14 are from what we did Monday, Tuesday, and Wednesday. All right, so the last 3. That has to do with the tangent and that stuff. All right, one of them is going to be a matching the graph. Okay, we're not really sketching anything by hand tomorrow for tangent and cotangent. Okay, you don't have to know any sketching by hand. But let's say I gave you a graph, something like this. And I gave you another graph. On the test, I'd probably give you 4 choices, but just to simplify it. And I said one of those is the graph of tan x, and the other one is the graph of 3 tan x. And I said match up which one is which. Tried to make it relatively clear, but which one would be which?
3 tan x would be on
Yep, it would be on the right because that's a vertical stretch. So imagine this was a piece of wire and you started stretching it. It would start to straighten out. So 3 tan x, tan x. The other thing you want to make sure you know how to do is type these in. I think you can all do sine and cosine, right? Even tangent, because there's a button for it. But what if I wanted you to graph cotangent? There's no button, so how do you type it in?
Is it negative? Or no?
It's like it's a negative tension.
What's the reciprocal?
Reciprocal. So how do you write, so if tangent is this, what's the reciprocal?
Oh, so 1 divided.
1 divided by tangent. That is the only way on this calculator to graph cotangent. So notice the curve on the cotangent goes the other way. How about if I wanted you to graph secant?
-1 and okay.
No negative. It's the same idea as the reciprocal.
Oh, 1 divided by
1 divided by what for secant? Cosine. So if I wanted you to graph secant, there's your secant. You get the U shapes and N shapes. What if I wanted you to graph cosecant?
Would be sine. Well, like 1 divided by sine.
Right, 1 divided by sine. Okay, so you want to make sure you know how to graph those. Let's take a look at secant. Or, let's do cosecant. Okay, so for that, let's find the domain, range, period, and asymptotes. Let's start with what we know how to do, and then if we need to look up some stuff from the notes today, we can go back and look at it. I think period would probably be the easiest thing to find. What's the formula for the period here?
that'd be 2 pi over b. B in this case is 3.
Nope. So period, done. All set?
Is it domain negative infinity over infinity?
Only for sine and cosine. Because sine and cosine don't have any vertical asymptotes. This one has asymptotes. So now, range, we could probably figure that out if we graph cosecant 3x. So that's how you graph cosecant 3x. Okay, so range, highest and lowest. Does it look like it's going down forever?
Yeah.
How about up forever?
No.
Well, I mean,
Oh,
on
yeah.
the top it is.
The top part goes up forever.
Yeah.
Does it hit every value in the middle?
No.
No, there's a gap. There's a gap where it never hits anything. So we go from negative infinity up to, how high does it look like that point goes?
1.
1. Negative 1. So the range,
So would it be negative 1, 1? But negative.
negative 1 to 1 are all the values you don't hit. From negative infinity to negative 1, or from what to what are going to be the values you do hit.
1 to
1
infinity.
to infinity. Alright, so there's my range. And now for asymptotes and domain, we've got to look at something we did today. Okay? We have to know where the asymptotes start for cosecant. So let's look up 6,4. So let's bring up that chart we had. Okay, cosecant. The asymptotes for cosecant start at 0 and pi. But we're changing them. So we have to figure out where they're going to move to. That's how we do it. Set the original asymptotes equal to the argument and solve. All right, so let's go back. What was one of the asymptotes?
0.
The other one?
Pi.
All right. Set each one of them equal to the argument. What's the argument there?
3x.
Yeah, that's what's in the parentheses. And now solve. Well, the first one, not much really happens. It's still 0. So that's 1. The second one, instead of the asymptote being at pi, now it's at pi over 3. Any questions on how we got those? Now, how often do those repeat?
They like add and subtract on each other, so like infinitely.
Right, they keep repeating every period.
Yeah.
Right, you're gonna get another dotted line. Well, we had it in the notes today, but you saw that. Okay, another dotted line every period. So now, let's go back to our chart. That's what I was looking for. You get another asymptote at regular intervals, okay, every period. So we take the two answers we just got, that's the x1 and x2, and then put that on the end, plus the period times n. Okay, so let's go back. What did we say the period was?
2 pi over 3.
Perfect, 2 pi over 3. So put plus the period times n. And same thing here. So what that means is you can add any multiple of 2 pi over 3 to your original asymptote and you will find another one. And then the domain is just everything except the asymptotes. Okay?
Sorry, I have to go.
Yep, that's fine. That's pretty much it.
Okay.
That's all. That's what's on the test.
All right. Thank you.
Yep, you're welcome. Right. So tomorrow, if there's any other questions, we'll review right before we take it.